There's now one last feature we need to take care of, which we have left to do later when we added our player camera. If you don't remember it by now, I've previously said that we will be enabling the virtual camera horizontal recentering option, which was the option that the free look camera didn't offer us. Now, what exactly is this horizontal recentering option and why do we really need it? Let's take a look at Genshin Impact. Currently, we are facing forwards while in the idling state. Let's say that we start moving to one of the sides, right or left. The moment we do so, we can notice that our player slowly rotates and moves in a circular motion. We can further notice this if we look down on the player at around a 90 degrees angle and start moving. What happens is that our player will rotate extremely fast. This happens even if we move backwards while we are looking down. This is achievable through the horizontal recentering option. Simply put, it automatically recenters our camera at a certain speed, also allowing us to set the time it should wait before it starts recentering. The speed of the recenter is called Recentering Time, which is how long it takes to recenter the camera. The time it should wait before it starts recentering our camera is called wait time. Of course, our player only rotates and moves in a circular motion because its movement is dependent on the camera horizontal axis. So by recentering the camera horizontally or in the horizontal axis, our player will start rotating itself and move with that rotation in mind. The higher the recentering time, the longer it takes to recenter the camera, which means the slower the player rotates. Of course, as we have seen before, different angles can have different settings or even enable or disable the recentering option. For example, moving backwards while looking forwards disables the option, while moving backwards while looking up or down enables it. To do this, we'll need to know the direction we are moving, which we can know through the movement input variable, and also the settings we want for each angle in each direction. To know those settings, we'll actually not use animation curves and use our own class this time, in which we can simply have a list of angle ranges and their recentering values. This is because I haven't found a way to have two different values in one animation curve, which will require us to have two animation curves, one for each value, which I found somewhat unnecessary as the values are updated for the same ranges. You are free to do it using two animation curves if you prefer to. With that in mind, we'll start by creating the class that will hold this data. To do that, go to the player data folder. In here, create a new folder named Cameras. Inside, create a new C# script to which I'll name Player Camera Recentering Data. When that's done, open it up. Remove the default methods and the monobehavior inheritance and make this class serializable. We'll create the angle ranges by typing in field, serialize field, field, range from 0f to 360f, public, float, minimum angle. I'll give it a private set. Then duplicate this property and name it maximum angle instead. Next we'll need one property for each of our recentering values, so duplicate the last property. I'll make the range be from -1 to 20f and rename it to wait time. Then duplicate this new property and rename it to recentering time instead. We made the minimum range value -1 as a way to specify that we want to use the default setting value, which we'll define later. Next, we need to create a method that tells us if we are within the angle range. So type in public bool is within range and pass in float angle. Inside, we simply return angle greater than or equals than minimum angle and angle lesser than or equals the maximum angle. When that's done, open up the player grounded data script. We'll be creating two lists of our class, one for recentering settings when moving sideways, and another one for settings when moving backwards or downwards. So, to do that, type in field, serialize field, public list of player camera recentering data named sideways camera recentering data. I'll give it a private set. Make sure you import the necessary namespace. Then duplicate the property and swap sideways with backwards, or downwards if you prefer. When that's done, save everything and go back to Unity. Open up the second inspector tab. In our sideways recentering data, we need two ranges, so add two elements to the list. The first one will be from 0 to 80, to which we'll pass in -1 for both settings. This of course means they'll use the default values we'll define later. The second one will be from 80 to 90, to which we'll pass in 0 for the wait time and 0.3 for the recentering time. That's it for our sideways data, so for our backwards data we'll be having one range, so add in one element to the list. The range will be from 80 to 90 degrees, to which we'll pass in 0 for the wait time and 0.5 for the recentering time. The horizontal recentering is disabled for any other angle range when moving backwards. Also note that while we are setting the horizontal recentering, these angle ranges are for the camera vertical angles. With that done, we'll set the player camera settings to their default values. So, select the player camera game object in the hierarchy and open up the aim area. Don't forget to go to the first inspector tab. In here, set the default horizontal recentering settings to 0 and 4. These are not really necessary as we'll be overriding them later, but it's always nice to have them set to the default values right away. We'll be defining these default values somewhere else as well, which will be in an utility script we'll be creating. This utility script will allow us to enable or disable our horizontal recentering option whenever we want to. To do that, open up the Player Utilities Scripts folder. In here, create a new folder named Cameras. Inside, we'll create a new C# script which I'll name Player Camera Utility. Open it up when you are done. Remove the default methods and inheritance and make it serializable. To get a reference to our horizontal recenter option, we'll need a reference to our camera POV aim. To get that, type in private SceneMachine POV, SceneMachine POV. Make sure you import the SceneMachine namespace. Above, we'll get a reference to our camera by typing in field, serialize field, public, SceneMachine virtual camera. I'll give it a private set. We'll also have a property for our default values, so type in field, serialize field, public float, default horizontal wait time, with a private set and a default value of 0f. Then duplicate this property and swap wait with recentering instead, and default it to 4f. To get our POV reference, we'll create an initialization method, so type in public void initialize. Inside, type in SceneMachine POV equals to virtual camera.getSceneMachine component of type SceneMachine POV. All that's left now is to create a method for enabling and disabling our recentering option. So start by typing in public void enable recentering. Pass in float wait time defaulted to -1f as the first parameter, and float recentering time defaulted to -1f as the second parameter. Then, under the enable method, create another one by typing in public void disable recentering. To enable our option, we'll type in scenemachinepov.m_horizontal recentering.m_enabled equals to true. We'll then copy this line and paste it in the disable method, swapping true with false instead. That enables and disables our option, but when enabling it, we also need to set our setting values, as we'll need them if that's the case. The first thing we'll do is actually cancel any existing recentering that the camera is doing, by typing in scenemachinepov.m_horizontal recentering.cancel recentering. I'm not entirely sure if Genshin does this or not, but I'll leave it as I think it fixed some weird recentering that happened without this. For our values, we'll first need to check if they are -1f, and if they are, we'll set them to their default values. To do that, start by checking if wait time equals to -1f, and if that's the case, we type in wait time equals to default horizontal wait time. When that's done, duplicate this whole if statement and swap the wait parts with recentering instead. To set our horizontal recentering option values, we now type in scenemachinepov.m_horizontal recentering.m wait time equals to wait time. Then duplicate this line and swap wait with recentering instead. And that's all we need to enable or disable our horizontal recentering option. We'll now add this utility as a property of the player script, so open it up. In here, create a new property by typing in field, serialize field, public, player camera utility, and give it a private set. I'll also add in a field header with the text of camera. Then, in the awake method, we need to initialize it by typing in camera utility.initialize. This simply sets our scenemachine POV component. When that's done, save it all up and go to Unity. In here, select the player game object and select or drag the player camera to the virtual camera field. That's our camera utility done, so we can now start thinking on actually recentering our camera. To do that, open up the player movement state script. We'll create two methods here that will call our enable and disable recentering methods, just so that we do not call in a big line every time, and also because we'll need to do something else later on when enabling it. To do that, go to our reusable methods region and type in protected void enable camera recentering and pass in float wait time defaulted to -1f and float recentering time defaulted to -1f. Inside, call in statemachine.player.cameraUtility.enable recentering and pass in wait time and recentering time. Then under this method, we'll create the disable method by typing in protected void disable camera recentering. Inside, we call in statemachine.player.camerautility.disable recentering. That's all that's needed for these two for now, so let's now create a method to update our recentering values. Above, type in protected void update camera recentering state and accept a vector2 named movement input. We'll understand in a bit why we'll be passing in a variable instead of using the movement input property right away. We'll have to disable or enable our horizontal recentering option depending on both the camera angle and our movement input. There is a situation that disabled our recentering option, which is when we stop moving. Instead of doing this here, we'll actually do that in the onMovement cancelled option. However, we only have one in our grounded state and none in our movement state, so we'll have to create another. To do that, head over to the add input actions callbacks method. Inside, add in a new callback by typing in statemachine.player.input.playerActions.movement.cancelled plus equals onMovement cancelled. Don't forget to remove it as well. I'll rename the parameter to context and then add this method to the input method's Recent. Because we leave it as private, it won't conflict with the grounded state method. Inside, call in disable camera recentering. Back into our update camera recentering state method, we'll still return if there is no movement input, so type in if movement input equals to vector2.0 and return if that's the case. Next, we'll need to disable it when moving forwards, as it sometimes seemed to give us a weird recentering even though it's supposed not to recenter in this situation. So type in if movement input equals to vector2.hub and call in disable camera recentering, returning right after as well. Then, we'll do it for when moving backwards, so type in if movement input equals to vector2.down. In this case, we'll need to iterate through our backwards list and see if it is within the ranges, disabling in case it isn't. Of course, to do that we need our camera angle, so above, outside of the if statement, type in float camera vertical angle equals to statemachine.player.mainCameraTransform.EulerAngles.x. Note that x is the camera vertical angle. Now we'll need to know if the range is between -90 and 90, as looking up has the same effect as looking down. However, we are only checking for positive angles in our lists, so we'll have to convert the negative values to positive using absolutes. To do that, type in camera vertical angle equals to matf.avs and pass in camera vertical angle. The reason why we are doing this here instead of above is because we'll need to add something else before we do this. Our Euler angles only return positive values. That means that -90 will be returned as 270 and so on. However, we want to make it 90 instead of 270 when making them positive. So we'll simply make it negative again by typing in above our second assignment if camera vertical angle greater than or equals than 270. If that's the case, we subtract 360 degrees to the angle by typing in camera vertical angle minus equals 360f. This shall now get us an angle between -90 and 90 and then make it positive so that we can compare it with our list angle ranges. We can now iterate through our settings list, so inside of the if statement, type in for each player camera recentering data, in movement data, backwards camera recentering data. Inside, we'll check if not recentering data is within range and pass in camera vertical angle. And continue to the next one if that's the case. Otherwise, we call in enable camera recentering and pass in recentering data.wait time and recentering data.recentering time. At the end, we return to exit the loop and method, as we have found the desired angle range already. If we did end up outside of the loop, then it means that we didn't find any setting with this angle, so we call in disable camera recentering and return right after. That's all there is for setting our values. We'll need to do this exact thing with our sideways list, so select the code we have just added except the last return statement and extract it to a new method. If you can't extract it, remove the return of the for each loop for a bit while you extract it. I'll name it setCamera Recentering State. I'll also pass in the list of the backwards recentering data and add it as a parameter. Then I'll rename the parameter to camera recentering data and import the list namespace. When that's done, swap the backwards list usage with the camera recentering data parameter. Don't forget to add the return statement back in our for each loop as well. I'll make this method protected just in case we ever need to reuse it somewhere. All that's left to do now is to add a setting for when we are moving sideways, because we have tested all other directions and also because diagonal directions seem to use the same settings as the sideways directions. We can just copy the method call we did for our backwards direction and paste it in right after the if statement without checking for anything. We'll then simply swap backwards with sideways to use our sideways data instead. And that's really all we need to do for our update camera recentering state method. Of course, we still need to call this method somewhere. We'll call it both when our movement input has changed and whenever our mouse has moved, as both of these mean that either our camera angle or our player direction have changed. So in our addInputActions callbacks method, in the reusable methods region, we'll add two new callbacks. StateMachine.player.input.playerActions.look.started plus equals on mouse movement started. And then StateMachine.player.input.playerActions.movement.performed plus equals on movement performed. Make sure you remove both callbacks. I'll rename both parameters to context and then add both methods to the input methods region. Again, the difference between started and performed in our movement is that started will only be called on the first key press, while performed means it will call on every key press, like going from W to WD. Our mouse started will be called quite a few times though, likely because of the way delta or the mouse works. In the onMouseMovement started method, we'll call in update camera recentering state and pass in statemachine.reusabledata.movementInput. In our onMovementPerformed method, we'll call in update camera recentering state. This callback here is the reason why we need to add the movement input as a parameter instead of using it right away. We are currently on the callback of the movement action. This means that the movement input we are reading in the update method isn't yet updated to the value that we have in this callback, as this callback is called before setting the value. This of course means that using the movement input property in our recentering methods will update the recentering state using the old movement input value. Thankfully, we can easily get the updated value here from the context variable. To do that, pass in context.readValue of type vector2. With that done, our camera recentering shall now be working, so save it all up, go back to Unity and enter play mode. Moving the camera around in the vertical axis or changing movement directions shall now move and rotate the player according to the settings list. However, we currently have a few problems in our implementation. The first problem you might have noticed is that our camera recentering rotation speed seems to depend in our current player speed. If we change between walking, running and sprinting, we change how fast our player or camera rotates. We'll fix this by making our recentering time be dependent in our player speed. The way we'll do that is quite simple. Let's say that for the speed of 5, which is our current base speed, we have a recentering time of 4. This means that for the speed of 10, we have x. This is of course a simple rule of 3. To get the x, which in this case is pretty easy for us as it should be 8, we multiply 10 with 4 and then divide it all by 5. This gets us exactly what we need, which is 8. However, it seems that we actually want the opposite. The higher our speed, the lower our recentering time should be. In this case, we want the result to be 2. To do that, we simply use the inverse rule of 3. The way we do that is by multiplying 5 by 4 and then divide it all by 10. This gets us the result we want, which is 2. We'll be adding this formula to our camera utility enable recentering method, so open up the player camera utility script. In here, in the enable recentering method, we'll be adding 2 new parameters at the end. Float base movement speed, defaulted to 1f, and float movement speed, defaulted to 1f. Then, before we assign our values to the horizontal recentering fields, we apply the inverse rule of 3 by typing in recentering time equals to recentering time multiplied by base movement speed divided by movement speed. Note that we do not use the multiply equals operator, as that will multiply the recentering time with the division of base movement speed by movement speed, which is not what we want. When that's done, go to where we use our enable recentering method, which shall be in our player movement state script. In here, we'll create a new variable by typing in float movement speed and assign it to be equal to get movement speed. Then we check if movement speed equals to 0f, and if that's the case, we set the movement speed to be equal to movement data dot base speed. This will make it so that we don't divide by 0, which shouldn't be possible, and instead divide by the base speed, which will make it so it returns the normal recentering time, as we are multiplying by base speed and then dividing by base speed again. When that's done, pass into the method call movementData.baseSpeed and movement speed. This shall take care of setting the correct values for different speeds, so save it all up and go back to Unity. Entering play mode, our speed shall no longer make our camera rotation faster, although it might not be a completely perfect solution. This, however, brings us to our second problem. Changing states, like going from running to walking, does not update recentering values until we change to a new movement input key. So moving to one side and pressing the Alt toggle keeps the recentering time the exact same, which means we still have our problem. The way we'll be fixing this is quite simple. Every time we enter a grounded state, we'll update our camera recentering state. To do that, open up the player grounded state script. In here, in our enter method, at the bottom, call in update camera recentering state and pass in state machine.reusable data.movement input. This seems like it will be enough, but we need to remember that this uses our speed modifier now. The problem with that is that we are currently only setting our speed modifiers after we call the base method, which means we won't have them updated by the time we call in the update camera recentering state method. To fix this, we'll go to every grounded state starting with the idling state, and in the enter method we'll place a speed modifier line to be above our base method call. Repeat this process for every grounded state that sets a speed modifier. With this done, we shall no longer have the problem we had. However, we also need to remember something else. We can enter and exit slopes, which update our speed modifier. This simply means that the moment the ground angle changes, we shall make sure we update recentering values to our new player speed. To do that is quite simple, as we have a method that returns us the new slope speed modifier. So, start by opening up the player grounded state script. In here, go to the set slope speed modifier on angle method in the main method's region. Inside, add in a new if statement by typing in if state machine.reusable data.movement on slope speed modifier is different than slope speed modifier. Make sure you place our current assignment in here. Then we'll also call in update camera recentering state and pass in state machine.reusable data.movement input. This makes sure our values are updated if our slope speed modifier is changed. If we save and go back to Unity, entering play mode shall now update the recentering values correctly. We do have two other problems to solve though. The first one is that our rotation stops when we cancel input, even if we currently are in the jumping state. So moving, jumping, and then unpressing the movement key will disable our camera recentering. In Genshin, this is not what happens when we are in the middle of the jump and should instead keep it enabled and rotating. To fix this problem, we'll simply need to override our onMovementCancel method and leave it empty. Of course, we currently have a private method in our movement state and a protected method in our grounded state, which means that we can't currently override it in our jump state. Thankfully, in the grounded state 1, we no longer need to change to the idling state, as no state does that when cancelling input anymore. So we'll simply remove it and make our movement state method protected virtual instead. To do that, open up the player grounded state script. In here, in the input methods region, remove the onMovement cancelled method. Make sure you also remove it from the add and remove input actions callbacks methods as well. When that's done, open up the player movement state script. In the input methods region, make our onMovement cancel method a protected virtual method. We now need to make sure that our currently overridden methods need to call the base method, or be removed if they were left empty to not transition to the idling state. So open up every grounded state script and do that. For the states that transition to other states in this method, we need to make sure we call the base method after we change states. This is because when changing states, we now call in the update camera recentering state method in the enter method, so it will enable it back after disabling it. When the grounded states are all updated, open up the player jumping state script. In here, add in a new region at the bottom named input methods. Inside, we'll override the onMovement cancel method and leave it empty. This should be enough, so save and go back to Unity. Enter in play mode. Moving, jumping, and releasing the movement key shall no longer disable our horizontal recentering. There's now only one problem left, which is that in Genshin, the walking state seems to have the default recentering time when we are looking down and move backwards. The idling state seems to also have a wait time when we are looking down and move backwards. For the sideways cases, both seem to still rotate fast and without waiting before recentering. The way we'll be doing this is quite simple. We'll simply create a reusable property that allows us to set the current backwards and sideways lists. To do that, open up the player grounded data script. In here, copy the backwards list property. Then open up the player walk data script. In here, paste the copied property under our base speed property and import the necessary namespace. We only need to override our backwards data, so we don't need to create a property for the sideways data. For our idling case, we'll need a new data class, so go back to Unity. In here, open up the player grounded data folder and create a new C# script which I'll name player idle data. Open it up and remove the default methods and inheritance. We'll make the class serializable as well. Then paste the copied property here. When that's done, go back to the player grounded data folder and duplicate the walk property. swap the walk parts with idle instead. When that's done, open up the player state reusable data script. We'll be creating a property to all these rotation values, so under our speeds and forces properties, paste the backwards property we have copied before twice. Then swap the second one to be sideways instead of backwards. This is just in case we ever need to override the sideways data as well. Remove the serialized field attribute and give them a public set. When that's done, go to the player movement state script. In the constructor, after setting our other variables, we'll type in statemachine.reusabledata.backwards camera recentering data equals to movement data backwards camera recentering data. Then duplicate this line and swap backwards with sideways. I'll extract both lines to a new method which I'll name setBaseCameraRecenteringData. I'll make this method protected and add it to the reusable methods Recent. When that's done, open up the player idling state script. In here, we'll create a new variable by typing in private player idle data. In the constructor, we then set the idle data to be equal to movement data.idledata. Then in the enter method, before we call the base method, we type in statemachine.reusabledata.backwards camera recentering data equals to idle data.backwards camera recentering data. Note that we need to make sure we set this before we call the base method, as otherwise our enter method update camera recentering state call will update with our old data list. We now need to reset this data whenever we leave the idling state by using our setBaseRotationData method. However, we can't really do that when we exit the idling state. This is because if we do that, then the moment we move, we'll set the values back to normal, meaning that our wait time will be set to 0 again, so we'll start rotating fast instantaneously. If we take a look at Genshin, if we wait until we are idle and start moving backwards while looking down, then we'll wait for a while before our recentering happens. However, if we start moving backwards while we are on a stopping state, it will be instantaneous and we won't wait for the recentering to start happening. This means that we can simply reset the values when we enter our stopping states. To do that, open up the player stopping state script. In the enter method, before we call in the base method, call in setBaseCameraRecenteringData. All that's left is our walking state, so start by copying the line in our enter method and then open up the player walking state script. In here, in the enter method, paste the line we have just copied before the base method call. Then swap the idle data with walk data instead. Make sure you create the walk data variable and set it in the constructor. When that's done, override the exit method. We'll need to reset the data back to its default values, which we can do by calling in setBaseCameraRecenteringData. That should set all the data lists correctly, but we of course can't forget to actually use the reusable properties in our methods. To do that, head back to the player movement state script. In our update camera recentering state method, in the reusable methods Recent, swap our movement data usages with statemachine.reusabledata instead. This should be enough to get it working, so save it all up and go back to Unity. In our second inspector tab, for our idle data, we'll only have one range. which will be from 80 to 90. For the wait time, set it to 0.25 and for the recentering time, set it to 0.5. For our walk data, we'll also only have one range, which will be from 80 to 90 with a wait time and recentering time of -1. If we now enter play mode, we should finally have our recentering working fine.